Method showColorDialog is called whenever we want to display the color dialog for the user that allows them to change the current drawing color. And of course that occurs when the user opens the app's context menu and then touches the option for setting the color. So the first thing we did in this example is to create a new dialog object using this as an argument, which is the context on which the dialog will be displayed, that is this activity, this doodles activity. Next, we inflate the user interface for that particular dialog, and we do that by using the colordialog.xml file. And we set the title on the dialog and indicate that it is cancelable. In other words, the user can touch the back button to dismiss the dialog without changing the color. Next, we obtain references to the 4 different seek bars, and this is important because programmatically we need to register their event handlers, and sometimes we also need to set their values as well, and we're going to do both in the next several statements. Next, at lines 245 through 248, we set each seek bar's on seek bar change listener to the object color seek bar changed, which we'll be defining down here in just a moment. Now basically, whenever any one of the seek bar values changes, we're going to update the on-screen presentation of what the drawing color would be if the user were to touch the button for setting the new color. So we set the listeners for each of those so we can get the change events and see what the new values are to create the new color. Then, based on what the current drawing color is, lines 251 through 255 position the thumbs on each of these seek bars to the correct location. And the way we do that is we call over to our doodle view to get the current drawing color, and it returns that as a 4-byte integer which contains components for the alpha, red, green, and blue values. And we can break out those components by calling color methods alpha, red, green, and blue respectively. These are static methods of class color that receive a 4-byte integer representing the complete color and then extract the appropriate byte representing the alpha, red, green, and blue values respectively. Those integers are passed to the seek bar's setProgress method, which positions the thumb on each seek bar to the appropriate location based on that component of the color. Next, at lines 258 and 259, we get a reference to our setColor button so that we can respond when the user hits or touches the button, and we do that by setting an on-click listener called setColorButtonListener, which we'll also look at momentarily. We indicate that our atomic boolean is true next so that we can ensure that if the user accidentally shakes the device while this dialog is on the screen, the separate thread that handles the sensor events won't display the dialog for confirming whether or not to erase the image. And then finally, we show the dialog last to get it onto the screen. Now, of course, once that dialog is on the screen, we can respond to the events of the GUI components within that dialog. So first we have our onSeekBarChange listener called colorSeekBarChanged that implements the onSeekBarChange listener interface. And that interface contains 3 methods, one of which we're actually using in this example, onProgressChanged, and the other 2, onStartTrackingTouch and onStopTrackingTouch, we don't need in this example, but we have to define them because in a Java interface, if you say you implement it, you must define all the methods of the interface. So going back to onProgressChanged, you can see that it receives 3 parameters: the seek bar that the user interacted with, an integer representing the value of the thumb when this method onProgressChanged is getting called, and a boolean indicating whether or not the change in the value of the seek bar was initiated by the user, true, or by the system or the application, false. So in this case, we are going to get this method called either because the program changes the value of the seek bars or because the user changes the value of the seek bars. And in either case, we still want to grab the current values of all the seek bars and display the current color that would be set as the drawing color if the user touches the Set Color button. So the next thing we do is we get references to all of the seek bars and the view called color view, which appears right below the seek bars. Then we tell the color view to set its background color, and we create a color out of the seek bar progress values. So for every seek bar we call get progress. That gives us the value of each of the 4 seek bars. And the color class's static method ARGB takes an alpha, red, green, and blue value in the range 0 to 255 for each and constructs a color object out of those values. That object is then passed to set background color, and that causes the color view's background to change color immediately. Now, if the user decides that they like this color and decides to set it as the drawing color, at that point the on-click listener will be invoked, called setButtonListener, which we registered up above. And when that on-click method gets called, we will grab a hold of the 4 seek bars once again. At lines 322 through 324, we will tell the doodle view to set its drawing color to the color returned by color.argb, and once again it's going to get the progress values from the 4 seek bars and construct a color out of that, pass it into the doodle view, and now the doodle view will use that as the drawing color going forward. Now, because we've touched the button in the dialog, we're going to dismiss the dialog. So we say dialog is visible is set to false, our atomic Boolean value that helps us keep the sensor event listener from displaying a dialog if in fact another dialog is on the screen. We then dismiss the current dialog, which removes it from the screen, and we set current dialog equal to null so that our reference that stores the current dialog that's displayed now is null, indicating there is no dialog in the system at the moment.